The Chevrolet small block engine is a series of automobile V8 engines built by the Chevrolet division of General Motors using the same basic small engine block. Retroactively referred to as the Generation I small block, it is distinct from subsequent Generation 2 LT and Generation 3 4LS, and Generation V engines. Engineer Ed Cole, who would later become GM president, is credited with leading the design for this engine. Production of the original small block began in the fall of 1954 for the 1955 model year with a displacement of 265 equillion, growing incrementally over time until reaching 400 equillion in 1970. Several intermediate displacements appeared over the years, such as the 283 equillion that was available with mechanical fuel injection, the 327 equillion, as well as the numerous 350 equillion versions. Introduced as a performance engine in 1967, the 350 went on to be employed in both high and low output variants across the entire Chevrolet product line. Although all of Chevrolet's siblings of the period designed their own V8s, it was the Chevrolet 350 equillion small block that became the GM corporate standard. Over the years, every American General Motors division except Saturn used it and its descendants in their vehicles. Finally superseded by GM's Generation 2 LT and Generation 3 LS V8s in the 1990s and discontinued in 2003, the engine is still made by a Graham subsidiary in Mexico as a crate engine for replacement and hot rodding purposes. In all, over 100 million small blocks have been built in carbureted and fuel-injected forms since 1955. In many respects, the later Generation 2 and Generation 3 engines still in production today for various vehicles still trace some of their design lineage to the small block design concept first laid down by Ed Cole and his team. The small block family line was honored as one of the 10 best engines of the 20th century by automotive magazine Ward's Auto World. The Chevrolet 90° V6 engine, which is still in production, is this original small block but minus cylinders number 3 and number 6. Overview: the first generation of Chevrolet small blocks began with the 1955 Chevrolet 265 equillion V8 offered in the Corvette and Bel Air. Soon after being introduced, it quickly gained popularity among stock car racers, becoming known as the Mighty Mouse motor, after the popular cartoon character of the time, with the simpler mouse becoming much more common as time went on. By 1957 it had grown to 283 equillion. Fitted with the optional Rochester mechanical fuel injection, it was one of the first production engines to make 1 horsepower per cubic inch. The 283 would later be extended to other Chevrolet models, replacing the old-style 265 V8s. A high-performance 327 equillion variant followed, turning out as much as 375 HP and increasing horsepower per cubic inch to 1.15. It was, however, the 350 equillion series that came to be the best-known Chevrolet small block. The engine's over-square 4.00-inch bore and 3.48-inch stroke are nearly identical to the 436 HP LS3 engine of today, but much has changed. Installed in everything from station wagons to sports cars, in commercial vehicles, and even in boats and airplanes, it is by far the most widely used small block of all time. Though not offered in GM vehicles since 2003, the 350 cubic inches series is still in production today at General Motors' Toluca, Mexico plant under the company's Mr. Goodwrench brand, and is also manufactured as an industrial and marine engine by GM Powertrain under the Vork name. From 1955 to 1974, the small block engine was known as the Turbo 5 V8, 3.875 inches bore family. All Chevrolet's V8s, from the big blocks to today's LS7 and LS9, evolved from the 265/283 small block family. Of the 3 engines in this family, 2 of them, the 265 and the 283, have gone down in automotive history. The first of this family was the 265, introduced in 1955. The 265 had a 3.75 bore, just like the 305. The stroke of the 265 was 3.00, like the 283. The 283, famous for being one of the first engines to make 1 HP per cubic inch, is also famous for being the evolutionary stepping stone that would later give rise to small blocks and to the W blocks, ultimately culminating in the Chevrolet big blocks. The last of this family was the 307, which was a stroke 283 with a medium journal. 265. The 265 V8 was the first Chevrolet small block. Designed by Ed Cole's group at Chevrolet to provide a more powerful engine for the 1955 Corvette than the model's original stove bolt and line 6, the 165 HP two-barrel debut version went from drawings to production in just 15 weeks. A pushrod cast-iron engine with hydraulic lifters, the small block was available with an optional 4-barrel Rochester carburetor, increasing engine output to 195 HP. The over-square bore, 3-in-stroke, engines 4.4-in bore spacing would continue in use for decades. Also available in the Bel Air sedan, the basic passenger car version produced 162 HP with a 2-barrel carburetor. Upgraded to a 4-barrel Rochester, dual-exhaust power pack version, the engine was conservatively rated at 180 HP. A shortcoming of the 1955 265 was that the engine had no provision for oil filtration built into the block, instead relying on an add-on filter mounted on the thermostat housing, and that was an option only. In spite of its novel green sand foundry construction, the 55 block's lack of adequate oil filtration leaves it typically only desirable to period collectors. The 1956 Corvette introduced 3 versions of this engine: a Euro 210 HP with a single 4-barrel carb, 225 HP with twin 4 barrels, and 240 HP with twin 4s and a high-lift cam. 283, the 265 V8 was bored out to 3.875 in 1957, giving it a 283 in displacement. The first 283 motors used the stock 265 blocks. However, the overbore to these blocks resulted in thin cylinder walls. Future 283 blocks were recast to accept the 3.875 bore. 5 different versions between 185 HP and 283 HP were available, depending on whether a single carb, twin carbs, or fuel injection was used. Fuel injection yielded the most power, topping out at 315 horsepower in 1961. Horsepower was up a bit each year for 1958, 1959, and 1960. The 1957 ramjet mechanical fuel injection version produced an even 1 HP per cubic inch, an impressive feat at the time. This is often thought to be the first US-built production V8 to produce 1 horsepower per cubic inch. However, it was preceded in this achievement by Chrysler in 1956. Besides being available in the Chevrolet line, it was optional in Checker taxis beginning in 1965. A version of it that was built by GM Canada was also available in Studebakers produced in Canada for 1965 and 1966. 307, a 307 Acclaim version was produced from 1968 through 1973. Engine bore was 3.875 inches with a 3.25-inch stroke. All 307s had large 2.45 inches journals. The crankshaft is sourced from the 327. This engine was also used by Holden in Australia and by General Motors' South African arm. This engine shares many of its dimensions with the 230 inline 6 and with the 153 4-cylinder, 4.00-in bore family. Originally intended as the performance block, this engine family through the 350 CID became an all-purpose engine that saw use in many applications from Corvettes to vans. All engines in this family share the same block dimensions and sometimes even the same casting number. The latter meaning engines were of the same block, but with different strokes. This engine family was updated in 1968 for the use of 2.45 inches medium-sized journals. The first engine in this family was the small journal 327 in 1962 and the last being 1992's medium journal 350. The medium Journal 350 would later be further developed into the Generation 2 LT1/4 350 in the early 1990s. 302, in 1966, General Motors designed a special 302 cubic inches engine exclusively for the production Z/28 Camaro in order for it to meet the Sports Car Club of America Trans Am Series road racing rules limiting engine displacement to 305 cubic inches from 1967 to 1969. It was the product of placing the 283 cubic inches 3.00 inches stroke crankshaft into a 4.00 bore 327 block. The 1967 302 used the same nodular cast iron crank as the 283-4, with a forged steel crankshaft that was also produced. This block is one of three displacements, 302,350, that underwent a crankshaft bearing diameter transformation for 1968 when the rod journal size was increased from the 2.00 inches diameter small journal to a 2.10 large journal, and the main journal size was increased from 2.30 inches to 2.45. The large journal connecting rods were heavier and used 3/8 inch diameter cap bolts to replace the small journal's 11/32. 1968 blocks were made in 2-bolt and 4-bolt versions, with the 4-bolt center 3 main caps each fastened by 2 additional bolts, which were supported by the addition of heavier crankcase main web bulkheads. When the journal size increased to the standard large journal size, the crankshaft for the 302 was specially built of tough dried hardened forged 1053 steel and fitted with a higher PM 8.00 inches diameter harmonic balancer. It had a 3/4 length semicircular windage tray, heat-treated, monofluxed, shot-peened forged 1038 steel pink connecting rods, floating pin in 69, forged aluminum pistons with higher scuff resistance and better sealing single moly rings. Its solid lifter cam, known as the 30-30 Duntov cam named after its .030/.030 inches hot intake exhaust valve lash, and Zora Arkus Duntov, the father of the Corvette, was also used in the 1964-65 Corvette 327/365 and Fi. 327/375 engines. It used the 202 2.02/1.60 valve diameter high-performance 327 double-hump 461 heads, pushrod guide plates, hardened blue stripe pushrods, edge orifice lifters to keep more valve train oil in the crankcase for higher PM lubrication, and stiffer valve springs. In 1967, a new design high-rise cast aluminum dual-plane intake manifold with larger smoother passage turn runners was introduced for the Z/28 that the LT1-350-1969 Corvette and 1970 Z/28 engines were equipped with until the Q-Jet carburetor returned in 1973. Unlike the Corvette, the exhaust manifolds were the more restrictive rear outlet log designed to clear the Camaro chassis front cross member. It had a chrome oil filler tube from 1967 to 1968, unique chrome valve covers that had neither the Chevrolet name or an engine displacement decal pad stamped into them, and a chrome 14.00 x 3.00 inches drop base open element air cleaner assembly on a 780 CFM vacuum secondary Holley 4-barrel carburetor. A divorced exhaust crossover port heated well choke thermostat coil was used to provide cleaner and faster engine warm-up. Its single-point distributor had an ignition point cam designed to reduce point bounce at higher PM along with a vacuum diaphragm to advance ignition timing at idle and part throttle for economy and emissions. Balancer and water pump pulleys, as well as optional power steering pulleys, were deep groove for fan belt retention at higher PM. In 1969, the 302 shared the finned cast aluminum valve covers with the LT1-350 Corvette engine. Conservatively rated at 290 HP at 5800 RPMs and 290 lb-ft at 4800, actual output with its production 11:1 compression ratio was around 376 HP with 1.625 inches primary x 3.00 secondary tubular headers that came in the trunk when ordered with a 1967 Z/28, and associated carburetor main jet and ignition timing tuning, Citation needed. In 1968, the last year for factory headers, they had 1.750 inches primaries x 3.00 secondaries. A stock 1968 Z/28 with a close ratio transmission, optional transistorized ignition and 4.88 gear, fitted with little more than the factory plenum cowl cold air hood induction and headers, was capable of running 12.9 second per 108 mph 1/4 mile times on street tires. After the 1967 Trans Am campaign with the 4-barrel induction system producing more horsepower than the competing automakers' 8-barrel systems, for 1968 Chevrolet developed a factory cross-ram aluminum intake manifold package using two Holley 600 CFM mechanical secondary carburetors for Trans Am racing. It was available only as off-road service parts purchased over the Chevrolet dealership parts counter. With the Chevrolet 141st design off-road cam, the package increased a stock 302's HP from 360 HP to approximately 400. Chevrolet went so far as to carry the positive crankcase ventilation system over to the cross-ram induction system to retain emissions compliance mandated for U.S.-produced cars beginning in 1967, that also provided full-throttle crankcase pressure venting to the intake air to burn its vapors. Engines prepared for competition use were capable of producing 465 HP with little more than the 8-barrel induction, ported heads with higher pressure valve springs, roller rocker arms, and the 754-second design road race cam. 1967/1968 model's cowl induction system had an enclosed air cleaner assembly ducted from its passenger side into the firewall cowl above the heater core. In 1969, factory ZL2 cowl induction hoods were available for both the single and dual 4-barrel induction systems that were sealed to the air cleaner base, ensuring cooler, high-pressure, dense air from the center of the base of the windshield was supplied to the engine for combustion smoothness and maximum power production. Another popular service parts-only component used on the 302 was the magnetic pulse Delco transistor ignition ball bearing distributor, introduced in 1967 and also used in the L48 427 Corvette, that eliminated the production breaker point ignition, allowing greater spark energy and more stable ignition timing at high engine speeds. Many of the 302's off-road service parts were the development work of racers like Roger Penske. Every part in OSCCA Trans Am engine had to be available through local Chevrolet parts departments to encourage their use by anyone who wanted them. While the 302 became a strong limited sportsman oval track racing engine in the hands of Bud Lunsford in his 1966 Chevy 2, its bore stroke and rod stroke geometries made it a natural high RPM road racing engine and were responsible for its being among the more reliable production street engines homologated for full competition across all the American makes, winning back-to-back Trans Am championships at the hands of Mark Donohue in 1968 and 1969. Trans Am rules required that all engine components have original equipment manufacturer production part numbers and be purchased through the respective factory dealerships. However, with engines built by Albarts, Faulconer and Dunn & Traco Engineering, the pinnacle of the 302's use in professional racing was its being the primary engine that powered the outstanding but overshadowed 1968 to 1976 SCCA Formula 5000 Championship Series, a Formula A open-wheel class designed for lower cost. The engine was also popular in Formula 5000 racing around the world, especially in Australia and New Zealand, where it proved slightly more powerful than the Refco Holden V8. Weighing 1350 lbs, with a 525-550 HP iron block and head engine positioned near the car's polar moment for responsive turn pivoting, a Hewland 5SPD magnesium transaxle, and 10 inches wide 13 inches front/20 inches wide 15 inches rear magnesium wheels, it produced incredibly exciting racing. They ran 0-60 mph in 2.8 seconds and over 180 mph. Reminiscing about the series, mid-70s Australian F5000 driver Bruce Allison said, we never used first gear at the start. We started in second, and even then there was so much torque, Euro unregistered trademark D-Get wheel spin through third and fourth gears. Euro prepared with a Lucas Mackay mechanically timed individual stack magnesium fuel injection induction system that was paired with ported production car double hump iron heads, a rev kit fitted roller lifter camshaft, roller bearing rocker arms, and a virtually stock production crankshaft. It had a lasting impact on the series' ability to conduct high car count finishes and close competition events by the degree of mechanical success it provided to a series filled with star international Grand Prix drivers like David Hobbs, Brian Redman, Jody Scheckter and Mario Andretti. 327, the 327 Italian V8, introduced in 1962, had a bore of 4 in and a stroke of 3.25 in. Power ranged from 210 HP L30 to 375 HP depending on the choice of carburetor or fuel injection, camshaft, cylinder heads, pistons and intake manifold. In 1962, the Duntov solid lifter cam versions produced 340 HP, 344 lb-aft with single cutter 4-barrel, and 360 HP, 352 lb-aft with Rochester mechanical fuel injection. In 1964, horsepower increased to 365 HP for the now dubbed L76 version, and 375 HP for the fuel-injected L84 respectively, making the L84 the most powerful naturally aspirated, single-cam, production small block V8 until the appearance of the 385 HP, 385 lb-aft Generation 3 LS6 in 2001. This block is one of 3 displacements that underwent a major change in 1968/1969 when the main journal size was increased from 2.30 inches to 2.45 inches. It's also interesting to note that in 1965 Chevrolet released the now legendary L79, which was nothing more than an L76, but with a 30-30 Duntov cam replaced by the number 151 hydraulic cam. The 327-350 HP engine could give many big blocks a run for their money. In 1966, Checker began offering the 327 as an option. The Avanti II and its successors were powered by the 327 and later versions of the small block V8. In 1968, the 327 was exported to Australia for use in the Holden HK Monero GTS 327. The engine was used in the Monero after development of the locally made Holden V8 engine fell behind schedule. The 327 was replaced in the 1969 Monero by the 350. 350. The 350 first appeared as a high-performance 295 HP L48 option for the 1967 Chevrolet Camaro. 1 year later it was made available in the Chevrolet Nova, and finally in 1969 the rest of the Chevrolet line could be ordered with a 350. The engine was also exported to Australia where it appeared in the Holden Monero from 1969 through 1972. Many variants followed, L48, years, 1967 Euro 1980, the L48 is the original 350 Italian, solely available for 1967 in the Super Sport version of Camaro SS 350 or Chevy 2 Nova in 68-79. In 69 it was used in almost all car lines. Camaros, Impalas, El Caminos, Chevrolets and Novas. 1969 L48's use a head cam, 4 barrels quadrajet carburetor, cast pistons, 4 bolt main casting number 010 blocks and casting number 041 or 186 heads. Power output was 300 horsepower and 380 lb-aft torque. Compression ratio was 10.25 to 1. The compression ratio of the L48 was lowered to 8.51 in 1971. In 1972 the only way to get a L48 in a Chevrolet Nova was to get the Super Sport package. This is indicated by the 5th digit in the van being a K. 1972 was the only year you could verify the Super Sport package by the van. The L48 V8 was the standard engine in the 1975 Euro 1980 Chevrolet Corvette. The L48 V8 Corvette engine produced 165 bhp in 1975. Power increased to 180 bhp in 1976 and stayed the same in 1977. 1978 saw 175 bhp for California or high-altitude areas and 185 bhp for everywhere else. Power increased to 195 bhp in 1979 and decreased to 190 bhp in 1980. L65, the 2-barrels carburetor 145 horsepower version of the LM1 350 inches. LM1, the LM1 is the base 5.7L with a 4-barrel carburetor 155-175 HP engine in passenger cars until 1988. Throughout its lifespan, it received either a points, electronic, and/or computer-controlled spark system, to conventional and feedback carburetors. The LM1 was superseded by the L48 power plant after 1988. ZQ3, years, 1970 to 1974. The ZQ3 was the standard engine in the 1970–1974 Chevrolet Corvette. It was a 300 bhp version of the 350 cubic inches small block, with 10.251 compression and hydraulic lifters. It used a Rochester 4MV Quadrajet 4-barrel carburetor. This was the first block produced that featured the larger 2.45-inch main bearing versus the older 2.30-inch main bearing in 1968–1969. Note: post-1971 blocks supposedly had a lower nickel content but thicker cylinder deck, and post-1974 heads of the small block Chevrolet used less iron, and were lighter weight, crack-prone, and less powerful because of the lower compression ratios used. In 1971, power decreased to 270 bhp and 300 pounds-ft of torque with 8.51 compression. 1972 saw 200 bhp and 270 pounds-ft of torque. In 1973 power decreased to 190 bhp, but increased slightly in 1974 to 195 bhp. L46, years, 1969 to 1970. The L46 became an optional engine for the 1969 Chevrolet Corvette. It was a higher performance version of the base 350 cubic inches V8 with casting number 4922.02 inches/1.60 valve heads and had an 11:1 compression ratio and produced 350 bhp. LT1. Years, 1970–1972, the LT1 was the ultimate 350 cubic inches V8, becoming available in 1970. It used solid lifters, 11:1 compression, the 178 high-performance camshaft, and a 780 CFM Holley 4-barrel carburetor on a special aluminum intake, with ram's horn exhaust manifolds in the Chevrolet Corvette, Delco transistor ignition and a low-restriction exhaust factory rated at 370 bhp in the Corvette, and 360 bhp at 6,000 rpms and 380 lb-ft at 4,000 in the Camaro Z28. Readline was 6,500 rpms but power fell off significantly past 6,200 rpms. The LT1 was available in the Corvette and Camaro Z28. Power was down in 1971 to dual-rated 330 bhp, 255 nethp and 360 lb-ft of torque with 9:1 compression, and again in 1972 to 255 bhp and 280 lb-ft. The LT1 designation was later reused on a Generation 2 GM MPFI 350 small block engine in late 1991, the LT1. L82, years, 1973–1980, the 1973–1974 L82 was a performance version of the 350 that still used the casting number 62476 cc's chamber 2.02 heads but with a Rochester Quadrajet 4 barrels carburetor and dual-plane aluminum intake manifold, the earlier L46 350 HP 350 hydraulic lifter cam, and 9:1 compression forged aluminum pistons producing 250 bhp and 285 pounds-ft of torque. Its cast aluminum LT1 valve covers were painted crinkle black contrasting with the aluminum manifold and distributor housing. It was down to 205 bhp and 255 pounds-ft of torque for 1975. It produced 210 bhp in the Corvette for 1976 to 1977. The 1978 L82 recovered somewhat, producing 220 bhp and 260 pounds-ft in the Corvette, and in 1979 it produced 225 bhp in the Corvette. In 1980, its final year, it produced a peak of 230 bhp. This engine was also available on the Chevrolet Camaro. L81, years, 1981, the L81 was the only 5.7L Corvette engine for 1981. It produced 190 bhp and 280 pounds-ft of torque from 8.21 compression, exactly the same as the 1980 L48, but added hotter cam and computer control spark advance, replacing the vacuum advance. The L81 was unique in that it was the only Corvette engine that employed a smart carburetor. The Rochester Quadrajet from 1980 was modified to allow electronic mixture control, and an ECM, supplied with data from an exhaust oxygen sensor, modified the fuel-air mixture being fed to the engine. LT9, years, 1981 to 1986, the LT9 served as GM's truck-based heavy emissions variant of the 5.7L supplied in K20 per carat 30 pickups and with the P30 chassis used for motorhomes and step vans. The LT9's listed specifications are 160 bhp at 3800 rpms and 250 lb-ft of torque at 2800 rpms with 8.31 compression. LT9s are carbureted with Rochester Quadrajets from factory and are generally 4-bolt mains. The LT9 is often known by van code as the M code 350. L83, years, 1982, 1984, the 1982 L83 was again the only Corvette engine producing 200 bhp and 285 lb-ft of torque from 9.1 compression. This was again the only engine on the new 1984 Vette, at 205 bhp and 290 lb-ft of torque. The L83 added crossfire fuel injection. Since GM did not assign a 1983 model year to production Corvettes, there was also no L83 for 1983. L98, for the new generation 4 V8, see GM L98. Years, 1985 Euro 1992. The new 1985 L98 350 inches added tuned port fuel injection TPI, which was standard on all 1985 Euro 1991 Corvettes. It was rated at 230 bhp for 1985 Euro 1986, 240 bhp for 1987 to 1989, and 245 bhp in 1990 to 1991. Aluminum cylinder heads were released partway through the 1986 model run, modified for 1987 with D-ports, and continued through the end of L98 Corvette production in 1991. The L98 V8 was optional on January 87 Euro 92 Chevrolet Camaro and Pontiac Firebird models 245 HP and 330 lb-ft. 345 lb-ft. 1987 versions had 10 HP and 15 lb-ft more and a change to hydraulic roller camshaft. Compression was up again in 1990 to 9.51 Camaro Firebird and 10.1 Corvettes, but rated output stayed the same. L05, the L05 was introduced in 1987 for use in Chevrolet GMC trucks in both the GMT 400 and the RV series trucks such as the K5 Blazer, Suburban, and rounded-era pickups formerly classed as the CK until 1991, which includes chassis cabs and four-door crew cabs. Although usage was for trucks, vans, and 9C1 option Caprices, the L05 was also used with the following vehicles: 1992/1993 Buick Roadmaster sedan and station wagon, 1990 Euro 1992 Cadillac Brougham, 1993 Cadillac Fleetwood, 1989 to 1993 Chevrolet Caprice 1A2 optioned special service station wagon, 1992/1993 Chevrolet Caprice wagon, 1993 Chevrolet Caprice LTZ, 1992 Oldsmobile Custom Cruiser wagon, 1995 to 1996 AMG Hummer H1. L05 usage was replaced by the LT1 after 1993 and GMB bodies until production ceased in 1996. In mid-1996 the L05 was equipped with Vortec heads used in the 1996 G30. L31. The Vortec 5700 L31 is a V8 truck engine. Displacement is 5.7 L. It is the last production generation I small block from Chevrolet. The cylinder heads feature combustion chambers and intake ports very similar to those of the LT1 V8, but without the reverse flow cooling. As such, the L31 head is compatible with all older small blocks, and is a very popular upgrade. It offers the performance of more expensive heads, at a much lower cost. It does, however, require a specific intake manifold. The L31 was replaced by the 5.30 L5300 Lumina 7. The 2002 model year was the final year for the L31 5.7 L small block V8 whose origins date back to 1955. The Vortec 5700 produces 255 HP to 350 HP at 4600 RPMs and 330 lb-ft to 350 lb-ft of torque at 2800 RPMs. It is currently being produced as a crate engine for marine applications and automotive hobbyists as the Ramjet 350 feet with minor modifications. Known as the Gen 1 Plus, this was the final incarnation of the 1955 vintage small block, ending production in 2005 with the last vehicle being a Kodiak Topkick HD truck. Volvo Penta and Mercury Marine still produces the L31. The marine intake is a potential upgrade for L31 trucks. Using this marine intake will allow the use of common types of injectors with various flow rates while still maintaining emission compliance. L31 applications: 1996 a Euro 2002 Chevrolet Express GMC Savannah full-size vans, 1996 a Euro 1999 Chevrolet GMC CK full-size trucks, 1996 a Euro 1999 Chevrolet Suburban GMC Suburban full-size long-wheelbase SUVs, 1996 a Euro 1999 Chevrolet Tahoe GMC Yukon full-size short-wheelbase SUVs, 1999 a Euro 2000 Cadillac Escalade, TBI L31 applications, 1996 G-Series vans over 8,500 lbg VWW/4. L80E transmission. Special applications: Oscar Mayer Airmobile, Isuzu box trucks, 4.125 in bore family, 400. The 400 Acclaim is the only engine in this family and was introduced in 1970 and produced for 10 years. It has a 4.125-inch bore and a 3.75-inch stroke. The 400 differed from other small blocks in that the cylinders were Siamesed and therefore required steam holes in the block, head gaskets, and heads to help alleviate hot spots in the cooling system at the point above the Siamesed cylinders. Overheating and damage are likely if head gaskets or heads without steam holes are used on a 400 block. The 400 is the only engine that uses a 2.65 inches main bearing journal and a 2.10 rod bearing journal. The connecting rod was also 400 specific, being 5.565 inches as opposed to the 5.7 rod used in all other small block Chevrolet engines. The 400 was made in 4-bolt main journal from 1970 to 1972 and in 2-bolt main journal from 1973 to 1980. The 400 can have either 2 or 3 cool plugs per side, though all 400 blocks have the provisions for a third cool plug on each side. The 400 was rated a 245 a Euro 265 horsepower through its life. The 400 saw extensive use in full-size Chevrolet and GMC trucks. K5 Blazer Jimmy, 1/2 ton, 3/4 ton, 1 ton, and even larger medium-duty trucks had an option to be equipped with the 400. The engine was available in mid-size A-body and full-size B-body passenger cars until the end of the 1976 model year. Early models produced 265 horsepower with a 2-barrel carburetor. All 400s came with a 2-barrel carburetor with a 4-barrel carburetor option becoming available in 1974. The 400 was never intended as a high-performance engine and never saw large factory horsepower numbers but had a reputation for great torque. It has since become popular for many types of racing, both on and off-road. 3.671 in bore family, designed and built during the era of the gas embargo, CAFE mandates, and tighter emissions, this engine family was designed to become Chevrolet's cost-effective, all-purpose economy V8 engine line. These were intended to fill the gap where the venerable 283 and 307 had been. This new engine family line would provide better gas economy than the larger 350, share its basic architecture and many parts with the 350 and would provide customers with more horsepower torque than Chevrolet's 70s era inline 6 and V6 engines. During the early 1980s, when GM was streamlining their engine lineups, the Chevrolet 305 would rise to prominence as General Motors' corporate engine, signified by being the standard V8 in many GM vehicles. Through much of the 80s, the 305 became General Motors' most common V8, followed closely by Oldsmobile's robust 307, similar in purpose, and based on Oldsmobile's very successful Rocket V8 architecture. The Chevrolet 305 also became the standard V8 in GM's CK Truck series, and even made an appearance in the Corvette for 1 year in 1980. The first engine in this family was the Medium Journal 262 in 1975, and the last was the Medium Journal 305. The Medium Journal 305 would, like its big brother 350, would be further developed in the 90s, although with a reduced stroke, into the Generation 2 SBC GMLT series engine L49 263. 262. The 1975 Euro 1976 262 was a 262 Akai and 90° pushrod V8 with an iron block and heads. Bore and stroke were 3.67 in by 3.10 in. Power output for 1975 was 110 HP and 195 lb-ft at 3600 RPMs. The 262 was replaced by the 305 for the 1977 model year. This was Chevrolet's second 4.3L displacement power plant. Three other Chevrolet engines displaced 4.3L, the Vortec 4300, the original 265 V8 in 1955, and a derivative of the Generation IILT engines known as the L99. This engine was used in the following cars: 1975 Euro 1976 Chevrolet Monza, 1975 Chevrolet Nova, early 1977 Pontiac Ventura, 305. The 305 5.0L variant of the small block Chevrolet was a 265 cubic inch block with a 350 crank. The bore was 3.736 inches and the stroke was 3.48 inches. Introduced in 1976 models, it had a displacement of 305 Akai and the 305 was used in the following cars: 1976 Euro 1992 Chevrolet Camaro, 1977 Euro 1993 Chevrolet Caprice, 1980 Chevrolet Corvette, 1976 Euro 1988 Chevrolet Malibu, Chevrolet El Camino GMC Caballero, and Chevrolet Monte Carlo, 1976 Euro 1979 Chevrolet Monza, 1976 Euro 1979 Chevrolet Nova, 1977 Euro 2003 Chevrolet GMC. Trucks, SUVs, vans, 1978 Euro 1987 Buick Regal, 1975 Euro 1979 Buick Skylark, 1991 Euro 1992 Cadillac Brougham, 1977 Euro 1981 Checker Marathon, 1991 Euro 1992 Oldsmobile Custom Cruiser, 1977 Oldsmobile Amiga, 1978 Euro 1980 Oldsmobile Cutlass, 1977 Euro 1981 Pontiac Catalina, 1977 Euro 1981 Pontiac Bonneville, 1982 Euro 1986 Pontiac Bonneville, 1978 Euro 1992 Pontiac Firebird, 1981 Euro 1987 Pontiac Grand Prix, 1978 Euro 1981 Pontiac Grand Le Mans, 1982 Euro 1986 Pontiac Parisienne, 1982 Euro 1985 Pontiac Parisienne Safari, 1979 Pontiac Sunbird. The Chevrolet 305 is a reliable, fuel-efficient V8, easily capable of 200,000 miles, if maintained. The initial two-barrel Rochester 2GC carbureted variants of the 305 were underwhelming, to say the least, pushing anywhere between 120 and 130 HP. From 1976 onward into the early 1980s, these engines were also prone to wearing out their camshaft lobes very prematurely due to a combination of improper manufacturing and reduced poor quality controls. The 305 engine is sometimes dismissed in performance circles because of its lack of power, its small bore size, and difficulty flowing large volumes of air at higher RPMs. However, two variants of the 8392 305 were notable performers, especially when in comparison to most of the other performance engines of that time, the 8388 L69 high output 5.0L, and the 8592 pounds-9 tuned port injection 5.0L. After 1996, its usage was limited to light trucks and SUVs until the 2000 model year as the Vortec 5000. The 305 is currently still in production as a marine power plant for Mercury Marine. California emissions, LG3, years, 1976 1980, this variant used a Rochester 2GC from 1976 to 78. In 1979, the more fuel-efficient Rochester dual-jet 2 barrels carburetor replaced the older 2GC. This change also resulted in a drop in the horsepower rating to 130 HP. All years had an 8.5:1 compression ratio. LG4, years, 1980 1988, the LG4 produced 150 HP 170 HP and 240 lb-aft 250 lb-aft. The engines saw a series of gradual improvements, increasing reliability, MPG, and power output. In 1978, some GM models were available with a Rochester 4 barrels M4ME carburetor, which offered a glimmer of some performance potential. For 1982, GM mandated that Pontiac discontinue their 301 V8 engines, resulting in a massive increase in LG4 production. Chevrolet also added GM's new computer command control engine management system to most LG4 engines. This included the very efficient Rochester 4 barrels E4ME Quadrajet, producing 145 horsepower at 4,000 RPMs, 240 foot-per-pound at 2,000 RPMs in the GMF body 145 HP. In 1983, Chevrolet replaced the cast iron intake with an aluminum version and utilized either 14,014,416 or 14,022,601, 601 heads with INT, 1.84/EXH, 1.50 valves, 58 cc chambers, 178 cc runners. For 1985, the 4-valve relief, flat-top pistons from the L69 were added to the LG4. Also added was a knock sensor to allow the CCC engine management system to compensate for the increase in compression and a more aggressive spark timing map in the ECM. As a result, power increased for the 1985 models to 165 HP from the 150 HP rating in 1984. For 1986, Chevrolet changed over to a one-piece rear main seal engine block designed to minimize leaks and warranty claims, however some early 86 blocks retained a two-piece rear main seal. For 1987, Chevrolet once again made some revisions to increase overall reliability. An all-new electronic distributor design was used. The intake manifold-to-head bolt pattern was redesigned to improve gasket integrity. Changes to the valve covers were also made. Ribbing was added to the top of the valve covers to increase surface area, acting as a heat sink. To improve intake gasket sealing, the mounting bolts were relocated to the valve cover centerline, placing all sealing pressure evenly upon the mounting flange perimeter. Thus these became known as center bolt valve covers. Another improvement was utilization of a hydraulic lifter roller camshaft on most 87 LG4s. Some early engines have lifter retainer provisions, but utilize the older, non-roller camshaft. 1987 would also be the last year for the LG4 production, however. A run of LG4 engines was made to supplement the carryover production for the 1988 Monte Carlo and the 1988 Caprice Pontiac Parisienne. LU5, years, 1982 late 1983, the LU5 Crossfire EFI 5.0L featured a dual-throttle body injection setup, based upon the original cross-ram intake supplied by Chevrolet for the 1969 Camaro Z28. Unlike the original 69 version, Chevrolet did not place it in the trunk for owners to install. The system utilized a special version of GM's still new CCC engine management system. Fuel was supplied by the two TBI units, set diagonally apart from each other, atop the unique, aluminum intake manifold. Unfortunately, the system was placed atop the basic LG4 and lacked any significant performance capability. The engine was originally planned for the long-awaited '82 Camaro Z28, however due to a last-minute GM-mandated cancellation of Pontiac's 301 V8 production and Turbo 4.9L project, the Crossfire 305 was made available in the '82 Trans Am. A 350 cubic inch version was also used in the Corvette. Being fairly early into GM's electronic engine management development and electronic fuel injection programs, few dealerships had the technology, equipment, or properly trained mechanics capable of dealing with these engines. Compounding these problems were widely varying fuel quality standards, production issues, poor quality control by GM, and owners who tinkered with a system they did not understand. In a very short time, these engines obtained the notorious nickname ceasefire engine. Today, owners with these engines note that they are fairly reliable, and that a significant upgrade can be made by simply using the L69 per pound 9 TPI L98 TPI exhaust manifolds/exhaust systems. When combined with performance-built stock 305 heads with larger valves or aftermarket heads, plus a camshaft upgrade, these engines can perform surprisingly well. Thanks mostly to a somewhat cult-like following, a number of aftermarket performance parts are also available through Crossfire specialized manufacturers. L69, years, late 1983 1988, the L69 high-output 5.0L was released late into the 1983 model year. It was optional only in the Firebird Trans Am and Camaro Z28, and was standard in the revived Monte Carlo Supersport. The L69 features a compression ratio of 9.5:1, for relief flat-top pistons, a unique and relatively aggressive stock camshaft, GMPN, 14,088,843 hydraulic flat tappet, duration at .050 inches 200-206, max lift, 0.403/.415-115, idle, 650 rpms, not a camshaft taken from another Chevrolet engine. It also utilizes a performance-tuned CCC ECM prom, a knock sensor, a performance-tuned D4M E750 CFM Rochester Quadrajet 4-barrel carburetor, and a special, free-flowing exhaust system with large-diameter exhaust manifolds, Y-pipe, catalytic converter, and exhaust system. Additionally, the engines came equipped with a functional cold air induction hood on the '83-84 Trans Am HO, a dual snorkel air cleaner assembly on the '83-86 Camaro Z28/IROC ZHO and '85-86 Trans Am HO, and a large, single snorkel on '84-88 Monte Carlo SS, an aluminum intake manifold, high stall torque converter in the Monte SS and 1984 F-body, or a lightweight flywheel on T5 ECT F bodies, and all utilized 373 axle gears. The Monte Carlo SS featured a special HD version of the THM 200R4 also used in the Buick Turbo Regal GN and Oldshurst Olds 442. The L69 engine produced 190 HP at 4800 and 240 lb-ft of torque at 3200 rpms in the F-body and was rated at 180 HP in the Monte SS. LE9, years, 1981 1986, The LE9 5.0L was a truck car version 4 barrels 650 CFM that also had a 9.5:1 compression ratio. The LM1 cam and 14,010,201 casting heads featuring 1.84/1.50 valves and 53 cc's chambers. The engine made 210 HP at 4,250 lb/ft at 2,000 rpms, LB9, years, 1985 Euro 1992. The LB9 tuned port injection 5.0L was introduced in 1985. At its core was the stout L69 short block and it utilized the same aggressive camshaft profile. The induction system was unlike any system used previously by GM. It featured a large plenum made of cast aluminum, with individual runners made of tubular aluminum, feeding air to each cylinder. And each cylinder had its own fuel injector fed by a fuel rail mounted above each bank. This engine was optional only in the Camaro Rock Z and Firebirds equipped with a WS6 suspension. In the Corvette, a 350cc version of this engine, the L98, was released. It would be 2 years before the L98 would be offered in the F-body 215 HP and 275 lb/ft and varied between 190 HP 230 HP 300 lb/ft of torque, over the years offered. L03, years, 1987 Euro 95. The L03 produced 170 HP and 255 lb/ft of torque. 170 HP at 4,400 rpm and 275 lb/ft at 2,400 in 1993 Euro 1995 grams trucks. This engine used the TBI throttle body fuel injection. It featured swirl port heads and served as the base engine in all CK1500 series GMC Chevrolet trucks vans. The Vortec 5000 L30 is a V8 truck engine. Displacement is 5,013 cc's. Bore is 95 ohm, stroke is 88.4 ohm. The compression ratio is 9.1:1. It is based on the Generation I small block from Chevrolet. It was replaced by the 4.8 L4800 LR4 for the 2003 full-size vans. In van configuration it produces 220 HP net flywheel at 4,600 rpms and 290 lb/ft net flywheel torque at 2,800 rpms. The engine uses a hydraulic roller cam and high-flowing, fast burn-style Vortec heads. Differences include bore and stroke, intake valve size, and smaller combustion chambers. L30 applications: Chevrolet Express, GMC Savannah, General Motors CK full-size trucks, 3.50 in bore family, 267. The 267 was introduced in 1979 for GMF body, G bodies and also used on GMB body cars. The 267 CID engine had the 350's crankshaft stroke of 3.48 inches and the smallest bore of any small block, 3.500 in. The 3.5 in bore was also used on the 200 Chilean V6, which was introduced a year earlier. It was only available with a Rochester Dialjet 210 Euro, effectively a Rochester quadrajet with no rear barrels. After 1980, electronic feedback carburation was used on the 267. The 267 also saw use in 1980 to 1982 Checker marathons. While similar in displacement to the other 4.3L, 265, a Euro 4.4L, 267, V8 engines produced by General Motors, the small-bore 267 shared no parts with the other engines and was phased out after the 1982 model year due to inability to conform to emission standards. Chevrolet vehicles eventually used the 305 Chilean as their base V8 engine. Major changes: the original design of the small block remained remarkably unchanged for its production run, which began in 1955 and ended, in passenger vehicles, in 2003. The engine is still being built today for many aftermarket applications, both to replace worn-out older engines and also by many builders as high-performance applications. The principal changes to it over the years include: 1956 a Euro full-flow oil filtration was introduced, using a paper element filter and a canister that was mounted to a boss that was added to the left rear cylinder block casting and machined for this purpose. 1957 The displacement of the base V8 continued at 265 cubic inches, but optional V8 engines were introduced with a displacement of 283 cubic inches. 1958 bosses for side motor mounts were added to the block casting, utilized for production mounts for this and all future model years. However, the features for front motor mounts as used in 1955 1957 remained part of the block casting in this and future years. The 265 cubic inch version of the engine was discontinued. Also, the cylinder head valve cover mounting bolt holes were changed from the top row staggered to the straight across pattern that remained the way of identifying the early heads from the newer ones with a valve cover design which lasted until the 1987 center bolt style covers. 1962 The block cylinder wall casting was revised to allow 4-inch bores, and the 327 cubic inch version of the engine, using this bore diameter and increased stroke, was introduced. 1967, the oil filter mounting now came from the factory with an adapter and machining to allow the use of spin-on filters. Canister mounting was possible by removing the adapter. 1968 The main journal diameter was increased from 2.30 inches to 2.45, and the connecting rod journal diameter was increased to 2.10 from 2.00. This allowed the use of cast iron crankshafts. The previous crankshafts were made of forged steel, which was more expensive. The rod bolts were changed from 11/32 diameter to 3/8. The oil fill location was moved from a tube on the front of the intake manifold to a cap on the left or right side valve cover, depending upon the application. 1970, the 400 is introduced in September 1969 for the 1970 model year, with a bore of 4.125, and a stroke of 3.75. This engine introduced the large journal crankshaft with the main journal size of 2.65. and rod bearing journals of 2.10. This engine also introduced Siamese bores to the Chevrolet small block line, requiring steam holes in the cylinder heads and head gaskets, which were used to prevent hot spots and subsequent overheating. The connecting rods, due to the long stroke, are also shorter at 5.565 inches, differing from all other 5.7 small block connecting rods. 1986 The rear main seal was changed from a two-piece rubber design to a one-piece rubber design that used a mounting appliance to hold it in place. This necessitated a change in the flywheel flexplate bolt pattern as well as requiring an externally balanced flexplate flywheel. 1987 The valve cover surfaces were changed so that the mounting lip was raised and the bolt location was moved from 4 bolts on the perimeter to 4 bolts along the center line of the valve covers. Also changed were the mounting angles of the 2 center bolts on each side of the intake manifold, and the lifter bosses were increased in height to accept roller lifters. The aluminum alloy heads for use on the Corvette engines retained the non-angled bolts. Also, all carburetors were replaced by TBI fuel injection. 1996 This was the last change for the Generation I engine, which continued through the end of the production run in 2003. All 1997 2003 Generation I engines were Vortec truck engines. The cylinder heads were redesigned, using improved ports and combustion chambers similar to those in the Generation II LT1, resulting in significant power increases. The intake manifold bolt pattern was also changed to 4 bolts per cylinder head instead of the traditional 6 bolts. See also, Buick V8 engine, Cadillac V8 engine, Oldsmobile V8 engine, Pontiac V8 engine, 1917 to 1918 Chevrolet Series DV8, Chevrolet Big Block engine, GMLT engine Generation 2 small block, GMLS engine Generation 3/4 small block, Chevrolet 90° V6 engine, a V6 version of the original small block removing cylinders 3 and 6, still in production. List of GM engines. References: Maguire, Bill. Horsepower Nation, Chevrolet's small block V8 celebrates its 50th birthday. Auto Week. Retrieved June 15, 2005. Sherman, Dan. The 10 Best Engines of the 20th Century. Ward's Auto World. Chevy Corvette 1955 Technical Specifications. Unique Cars and Parts. Flory, J. Kelly, Junior American Cars 1960 Euro 1972, pages 341. Braunschweig, Robert. A.L., eds. Automobile Review 7166. Bern, Switzerland, Horvath SAPA 242. Flory, pages 411. ABCDE Gunnell, John. Standard Catalogue of Corvette, 1953–2005. Krauss Publications, 2004, ABC Gunnell, John. Standard Catalogue of Corvette, 1953–2005. Krauss Publications, 2004, Gunnell, John, 360 bhp with the Camaro's log manifold exhaust system and points ignition. Standard Catalogue of Corvette, 1953–2005. Krauss Publications, 2004, Chevy Truck Engine Specifications, RPO Codes, Horsepower, Displacement, Torque Ratings, Chuck's Chevy Truck Pages.com. ChuckChevyTruckPages.com. Retrieved November 22, 2013. ABLT9 Engine, Chevy Talk, the social network for Chevy fans. Chevy Talk. Retrieved November 22, 2013. Chevrolet Pickups 1973–1998, How to Identify, Select and Restore Collector. Google Books. Books.google.com February 23, 2008. Retrieved November 22, 2013. Call Plug, information on the Chevrolet C1500 with L30 engine. Automotive.com. Retrieved January 25, 2012. Standard Catalogue of Independence, pages 41–42, external links, Mortke, Small Block Engine Enthusiasts.